Half day students, this is actually another video for today. I actually noticed that they added a little bit to this topic. So we're going to look at rational equations. So just building up a little bit off of last topic's work with rational expressions. So first of all, we're going to look at how to solve equations with rational expressions. So in general, when you have a fraction is equal to a fraction, you can cross multiply, meaning I'll multiply here, let me just do this here. A times D by, and then B times C, and then they will equal each other when you cross multiply. So there are certain steps to solving equations with rational expressions. So you want to simplify each side, so the left and the right side of the equation, into one fraction. From there, you cross multiply and make them equal each other, and then if there's a first degree equation, meaning that x or your variable is only to the first power, you just solve by isolating that variable. If a second degree equation, meaning that I have a variable to the power of 2 as my highest degree, then that's where you'll solve by factoring, by moving it all to one side, putting it in general form, and then factoring, and then solving for your variable. And then lastly, you have to check if any solutions must be excluded. And we'll go over this. Basically, we're going to keep in mind the one thing in math that we can never do. We can never divide by 0, right? So you're going to check all of your solutions and see if any of them would make your denominator 0. And if then, we'll have to exclude those. Okay, looking at this first one, 6 over y minus 2 equals 3 over y. I already have one fraction on each side. I'm just going to cross multiply and then solve from there. So crossing these, I'm left with 6y is equal to 3 times y minus 2. I'll multiply this out and then isolate y. So we have 6y is equal to 3y minus 6, distributing that. Moving 3y to one, or moving the y to one side, so I'm going to have minus 3y minus 3y. This is canceled. I'm left with 3y is equal to negative 6. Dividing by 3, I have a y value of negative 2. What I want to do now is see if it'll make either of my denominators to be 0. So negative 2 minus 2 is going to be negative 4, so that's okay. Negative 2 is obviously not equal to 0, so that's good. Okay, so we don't have to exclude it. This is our solution. Always make sure you look for the exclusions, just because there may be one that you have to exclude. So yeah, it'll be marked wrong if you leave it, so make sure you always check. Okay, so we have this. We have a fraction over a fraction. I'm just going to multiply, cross multiply, and then equate them to each other. So we have 5 times 4x minus 12 is equal to 1 times 8x minus 24. I'll distribute and solve. So we have 20x minus 60 is equal to 8x minus 24. This is of the first degree. I'm just going to isolate x by subtracting 8x. So I'm left with 12x. I'm going to add 60 to the other side. That'll give me 36. Sorry. Dividing by 12, x is equal to 3. So I'm going to check real fast. Does 3 make my denominator 0 anywhere? Look at this first one. Let's plug it in. 8 times 3 minus 24. That's going to be 24 minus 24. So the value of 3 for x will make my denominator 0. So I actually have to exclude 3. We're excluding x is equal to 3. Therefore, so I really honestly don't have a solution. So I'm going to reject x is equal to 3. And there's nothing else I can do from there, so I'll just leave it as that. Okay, again, first thing I need to do is make sure that I have one fraction on each side. So x over 2 plus x over 3, I'm going to use what I know about least common denominators and things like that to make it into one fraction. I know the LCD of 2 and 3 is 6. I have to multiply this first one by 3, right? Because in order to get 2 to 6, I had to multiply by 3 on the bottom. So multiply the top by 3. Same for this. I'll multiply both sides by 2 to get 6. 5, I might write that as just 5 over 1. Okay, so from here, I can combine these. 3x plus 2x is just going to be 5x. So I have 5x over 6 is equal to 5 over 1. From there, I'll cross multiply. So I have 5x is equal to 30. Dividing by 5, x is equal to 6. There's no variables in my denominator, so there's nothing that will make my denominator 0, so that's our answer. Looking at letter D, the LCD of 4 and 8 is going to be 8. I want to multiply this by 2, right? And then the y for the 8 is going to stay the same, equals 2 over 1. Okay, combining these, 2y minus y is going to be just y over 8, equals 2 over 1. Cross multiplying, I'm left with y times 1, so we have y is equal to 2 times 8, 16, and then that's it. Again, there's no variables in the denominator, so I don't need to check. Y is equal to 16. Okay, so for this one, what I'm going to do is going to combine my left side into one fraction by first finding my LCD. LCD of 2 and 6 is 3. So LCD of 2 and 6 is 6. So I'm going to have to multiply my first term there by 3 over 3, right, in order to get my denominator to 6. So I'm going to have 3 times x plus 2 over 6, and that becomes 6 if I put 2 times 3, right? Plus 3 over 6 can stay the same. 3x minus 4 over 3. From here, I'll distribute this 3 and then combine it with the other 3. So we have 3x plus 6 when I distribute, plus 3 to add to the other side, and then combine it all under 1, 6 is equal to 3x minus 4 over 3. We'll simplify. 3x plus 9 over 6 is equal to 3x minus 4 over 3. Now we can finally cross multiply now that I have a fraction is equal to a fraction. 3 times 3x plus 9 is equal to 6 times 3x minus 4. Okay, multiplying it out, and then we'll solve for x. So we have distribute 9x plus 27 is equal to 18x minus 24. A lot of steps for this one, so I'm going to subtract x from 9x on each side. We have 27 is equal to 9x minus 24. I'll add 24 to each side. So I'm left with 3. Oh no, sorry. Adding 24 to 27, we'll get 51 equals 9x. Divide each by 9. I'm left with 51 over 9 is equal to x. You have to make sure that your thing is in the simplest terms. This one, okay, it looks like we cannot divide it more, but each of these is divisible by 3. You can tell something's divisible by 3 if you add up all the digits. So this 5 plus 1 is 6. Since that's equal to 6, that's actually divisible by 3. So 51 divided by 3 is going to be, so we have 30 and 21, so that one's actually going to be 17. Again, you can do it on the side, your long division if you want. 17 over 3 is going to be the value of x. Okay, and it's always preferable to leave it in, please leave it in fraction form, no decimals, okay? That's like a waste of time. So 17 over 3. And then again, I have no variables in my denominator, so I don't need to check anything. We only need to check when the variable could possibly make your denominator 0. And if there's none in the denominator, then it makes sense that it cannot change it. Last one, for one like this, we have 3 over x squared plus 2 over x. Finding the LCD of that, the LCD is going to be x squared. So we have 3 over x squared, it's going to stay the same, plus, and then I'm going to have to multiply this by x over x, right, in order to get it to x squared. Combine this into 1, so we have 3 plus 2x over x squared is equal to 1 over 1. From there, I'll cross multiply, so that'll give me 3 plus 2x is equal to x squared. And then this one, we have a thing of degree 2, so I'm going to move it all to one side, factor, and then, what's that called? Solve. So I'm going to move everything to the right side, so it's going to be 0 is equal to x squared minus 2x minus 3. Okay, so from there, okay, I can say, what factors of 3 will give me a difference of 2? So it's going to be negative 3 and positive 1. X minus 3, x plus 1 is equal to 0. From here, I'll solve for x. I know the two values of x are 3 and negative 1. Next, I need to check, do I need to exclude anything? Well, either of these give me a denominator of 0. 3 squared is 9, 3 is 3, negative 1 squared is 1, negative 1 is 1. So neither will give me 0 in denominator, so both of them are fine. So those are my solutions. Moving on now to our last problem. This is a word work problem. So when we're talking about work, usually it's about a person can do something in a certain amount of time, person B can do it in a different amount of time. How fast will it take, or how long will it take them if they do it together? So we're going to use this where we have a rate, which is the amount of work over time, and then rate A plus rate B is the rate together. So if Anna can build a shelf in 120 minutes, Nate can build a shelf in 80 minutes, we want to see how long it would take them to build the shelf together. So first of all, it's going to be work over time. So I can say Anna's, the rate of Anna, is going to be 1 shelf over 120 minutes, right? Nate, the rate of Nate, is 1 shelf in 80 minutes. How long would it take them to build the shelf together? So the rate together, I want to see how long it takes them to bring 1 shelf, right? So the rate together is going to be 1 shelf in X amount of minutes, an unknown amount of minutes. So what I'm going to do is, when I say, okay, I already know the rate together, I'm going to add them together. 1 over 120 plus 1 over 80 is equal to 1 over X. And now it looks like something that we just did. So what I'm going to do is combine my left side and then cross multiply to solve for X. So 1 over 120 plus 1 over 80. I have to find the LCD of 120 and 80. That one's going to be 240. So I basically just thought of 8 and 12. So it's going to be 240 plus over 240. To get 80 to 240, I had to multiply it by what number? We had to multiply it by 3, right? To get 120 to 240, I had to multiply it by 2. So I'm left with 2 over 240 plus 3 over 240 is equal to 1 over X. I'll combine these into 1, so it's going to be obviously 5 over 240 is equal to 1 over X. Cross multiplying, I have 5X is equal to 240, dividing it by 5. I'm left with X is, let me just do this on the side here. 240 divided by 5. We have 4 times 5 is 20, 48. So it's going to take them 48 minutes to build the shelf together. So I might actually just, you have to always put, for word problems, answer in a sentence, or at the very least, label it. So 48 minutes to build the shelf together. And that's actually it. That's it for topic 13. Hopefully it's okay for you. Just kidding. I'm actually adding one more problem. Okay. I forgot that they want one more thing. Okay, so for this last part, it's actually just about solving for a certain variable. You just want to isolate the variable, even though there's other variables involved. So for example, if I was to have xy is equal to z minus, what's that called, ky, and it said solve for y. So for this one, I want to put all my y's on one side and then see what I can do from there. So I want to move this minus ky to the other side by adding ky to each side. So I'm left with xy plus ky is equal to z, right? I added it to the other side, it canceled on the right side. Once I have this, I want to make y be by itself. So a way for me to get y by itself, I can factor y out of these. X plus k is equal to z. From here, y times something equals to z. So to get rid of this x plus k, I don't care about getting rid of it individually, I just want to get it away from y. So I'm actually just going to divide all of it by x plus k. And whenever you're doing these, you're really just going to concentrate on the variable that they're telling you to solve for. And then everything else, I just want to work on getting it away. We don't have to think about too much about distributing, things like that. Just get everything away from the y. And if there's more than one y to the same power, just try to see if you can move whatever has that variable in it to one side and then factor it out and then divide whatever else is there. A simpler problem, if it said solve for x and we had 6x plus 3y is equal to -4. Okay, and I said solve for x, I would just move everything away from the x first, right? Subtract 3y, 6x equals -3y minus 4 divided by 6. So we have x is equal to -3y minus 4 over 6. You don't really need to do anything from there. We're fine. That's really it. Hopefully the test is okay for you. Good luck.